Alright, so we're taking it up from last time we were talking about functions. Now we're going to talk about composite functions. Alright, so let's take it up from here and let's keep reading. One concept that comes up in AP Cal is composition of functions. The format of a composite of functions is plug a value into one function, determine an answer, and plug in that answer into a second function. Okay. So what they usually do is they end up giving you two functions, and I'm actually going to rewrite this on a separate page here. So they end up giving you two functions. So here they say f of x equals x squared minus x plus 1, and g of x equals 2x minus 1. It says find f of g of negative 1, find g of negative 1, and then we're going to show that they're not equal. Okay, so how do we deal with this? Well, the first thing you want to do, and the first thing I'm going to do at least, is rewrite the problem. I need some space to illustrate what's going on here. So we have f of x equals x squared minus x plus 1, and g of x equals 2x minus 1. Okay? If I'm solving for f of g of negative 1, this is how we're going to approach this. Step 1, ignore everything but the inside. Okay, so we're going to look at g of negative 1. By the way, why do we do this? You should always be asking this question of why do I do this? And the reason why we do this is when we talk about functions, or we do mathematics, we follow mathematical grammar. We say we follow PEMDAS, and PEMDAS says you just tackle what's inside first. So we're going to tackle this g of negative 1. Well, what I said, how do we do this? We write g of x on top, which is 2x minus 1, and then g of negative 1 on bottom. And we're going to substitute in. So 2 times negative 1 minus 1 is negative 2 minus 1, which is negative 3. So what am I saying here? Well, what I'm saying is g of negative 1 is negative 3. So now up here, when I say f of g of negative 1, I'm no longer saying f of g of negative 1. Or I am, but I can also say f of negative 3. So g of negative 1 is negative 3, so instead of g of negative 1, I can now say negative 3. Okay, just substituting in values. And now we solve for f of negative 3. So again, rewrite the original function, x squared minus x plus 1, and then I'm going to write what x is. So again, x is negative 3, so negative 3 equals negative 3 squared minus negative 3 plus 1. And then I solve. So negative 3 squared is 9. Negative becomes a positive, so another positive 3 plus 1. So that's 9 plus 1 is 10, plus 3 is 13. So this equals 13. So you'll see here, that's exactly what they did. 2 to negative 1 minus 1 is negative 3. Just wrote it vertically. Then they plugged in that negative 3 to the next one. 9 plus 3 plus 1. Ooh, look at that. 9 plus 3 plus 1 is 13. Alright, so this is really nothing more. That's why I say the functions are like the Glade song. Plug it in, because that's all you're doing. You're just substituting in one value for the other. So you're just playing this massive game of substitution. Okay? So if I do the next one, they switch f and g. So now they're saying g of f of negative 1. So what I do here is, again, we do what? We start with the inside, so f of negative 1. Okay, so we start with f of negative 1. And I'll start rewriting the initial statement above. So f of x equals x squared minus x plus 1. And directly below, I'll write what x is. So I'm going to end up getting 1 plus 1 plus 1. Why? Negative 1 squared is what? Negative 1 times negative 1, which is 1. Negative is a positive, and 1. So this gives me 3. So f of negative 1 is 3. And I'm going to replace f of negative 1 here with just that, 3. And I'm going to solve for g of 3. So how do I solve for g of 3? Remember, directly above you write what it's equal to. So 2x minus 1, and every x is now 3. So 6 minus 1, which is 5. So note that earlier we got 13, here we got 5. So in question C, it says, are they equal? They're clearly not, because one's 13, the other one is 5. So f of g of negative 1 does not equal to g of f of negative 1. Okay, so the question then becomes, are they never equal to each other? And the answer is no. Sometimes this does work. Sometimes you can have f of g of x equal to g of f of x. Here it's not, but that's not always true that it's not, okay? It is, however, true, we can from this deduce that f of g of x does not always equal to g of f of x, okay? Note I said does not always. It can, but it doesn't always, and so that statement is never 100% true. Okay, hopefully that makes sense. If we look over here, we can see that we showed that it's true. Now what's interesting is, you can tell that I wasn't even looking at the answer key. When I solved this, it says show that f of g of x does not equal g of f of x. What's interesting here is they did it a different way. They actually used the functions to solve it. So again, they took 2x minus 1, they squared it, and then they combined like terms, and they got 4x squared minus 6x, and then they did the same thing with the other function, and they got what it's equal to, and they showed that they are not the same thing via equations. Is that to say what I did is wrong? No. And this is the beauty of math. Okay, this is called this is a mathematical technique to show a statement is true. It's kind of like what's called proof by contradiction. So what I did is, if you can find one case that does, not really proof by contradiction, I'm sorry, this is basically something that's very useful in math, which is that if you can find a case that a statement doesn't work, then the statement is not true. Okay, so the fact that I showed that 13 doesn't equal 5 deduces that f of g of x does not equal to g of f of x. That's a valid proof to say that these functions are not always equal. Okay, so note that this is probably a clear explanation because it's saying for any x value the statement is true, but what I did is perfectly fine as well. So either scenario, perfectly acceptable. All right, I'm gonna stop here. Post some comments. I'm starting to get in a little fancy sort of abstraction talk, and if that's not making sense, let me know. I can always redo something if that would help you guys out. So there you have it. We'll pick up with piecewise functions in the next video.